Hello guys, welcome to my channel. In this video we are gonna solve GFG problem of the day. In this day they have given the remove BST keys outside the given range. They have given some range L and R values. We have to make sure that every value which is present inside that tree should lies in this range. If it does not lies in that range, then we are allowed to delete that value, right? See, in this example 6 minus 13 8 and 14 13 7 and 15, we have to check for each and every value. So we are gonna using a recursion here, recursion, and we are gonna use a deleting a value from the BST. So before solving this problem, make sure that you know these two. If you know these two, then it will be a piece of cake for you. So let us traverse and let us find. Okay, first of all we have to check the node value. If it is lies in that range, then we have to check for the left part and we have to go for the right part. So in this case we are currently at 6. We are checking whether it lies in this range or not. Yes, it lies in this range. Then we have to go for the left part, we have to go for the right part. Why? Because there may be some values which lies outside the range. There may be some values here which is greater than 13. So there may be some values which may be lesser than the 6 in the left subtree. Yes, in this case we have 13. So this is the base case, right? We have to check for, if it does not lie, then we have to go for. So then first we will traverse for the left. In the left we have 13. Similarly, we have to check for the range here. We have to check for the range here. Here minus 13, which is does not lies in that range. Then what we have to do? We have to simply delete this value. So deleting this value is little bit tricky. Why? Because there may be some values, like we have to check for the left part, we have to check for the right part. There may be some values which have like left side of the 13 and right side of the minus 13. So in this case, what if the value is minus 5? Can we simply delete this left subtree? Yeah, in this case we can delete this. Why? Because all the values which is present in the left subtree of minus 13 usually have lesser than the 13. So we can simply delete the left subtree here. And what about the right subtree? Can we simply delete the right subtree? No, we cannot delete that. Then what we have to do? We have to check for the right subtree and we have to give the matching subtree, and we have to attach this to here. So like see, if 13, 6 and 13 is present, minus 13 in the tree, and we are having 8, right? So we have to check for the minus 8 here and we are gonna attach this node to here. So the new tree will become 6 and minus 8. So basically we are deleting this node and we are attaching this one. And what about the right subtree? First of all, check the range, whether it is lies in that range or not. In this case it is not. Then we have to decide whether which part we have to delete. In this case, can we delete the left part? No, we cannot delete, right? Because all values which is lesser than the 14, and there may be some values which may be greater than which may be lesser than the minus 13. In this case we have, right? So we cannot simply delete the left subtree. Can we delete the right subtree here? Yes, we can simply delete the right subtree, because all values usually greater than, if it is 14 is greater than 13, then all values usually greater than the 14, which is usually greater than the 13. So we can neglect this value. Then what we have to do? We have to check for this case, right? We will make another recursion call and we will attach this node to here, this node to the right subtree of the 6. It may be a little bit confusing, but in the code it will be lesser than the 10 lines. So let us code and let us understand the flow. As usual, first we will have to check for the root equal to null. Then we are returning the null. Then what we have to do? We have to check for the range, right? This is the second test case. If root dot data which is greater than or equal to L, and root dot data which is less than or equal to right. This is the case. See here it is lies in that range. Then what we have to do? We have to go for the left part, we have to go for the right part. So checking the subtree is usually calling this function itself, and in the placeholder of root we are passing root dot left and int L and int R. So this function solve the left subtree and this function solve the right subtree. It will return the two nodes. Sorry, we have to reopen. We should not pass the data type here. It will give the subtrees, left subtrees and the right subtrees. Then we have to attach these subtrees to that current node. So root dot left will be this one and root dot right will be this one. It will be the left subtree. All values usually lies in this range, and we are attaching that node to the left subtree, left part of this node and right part of this node. Else, what if it does not lies in that range? Here minus 13 does not lies. So there are two possibilities. Either it can be lesser than the L value or it can be greater than the R value. So let us check. If root dot data which is lesser than the L value, then what we have to do? We have to check for the, if it is lesser than the left part, okay, which is lesser than the L, then we have to check for the right part, right? So here 13 is lesser than the L, that is minus 10. Then what we are doing? We are checking for the right part, right? Here minus 8. We cannot simply attach here. We have to check. To check that one, we have to call this function itself. We are checking the right subtree. It may be a little bit confusing, but we have to return this one. So here it will return minus 8, right? It will return minus 8, and this minus 8 will come here since we are calling the left part, and this minus 8 will attach to the root dot left. So 6 dot left is connected to minus 8. If root dot data is greater than or, then what we have to do? We have to check for the root dot left L and R. So here 14 is greater than the right value, then we have to neglect this value. We have to neglect the right part, and we have to only check for the left part. Why we cannot directly attach this 13 to here? Because what if 15 is present here and 14 is present here? So we have to check there. So I will call this function. It will solve for the left subtree, and it will give the node. It will give the node root of the left subtree, and in this node it will be attached here, whether it are left or right. It can be left or right, and in the parent file it will be checked. By default, return root. So 1, 2, 3, 4, 5, 6, 7, 8. Which is less than the 10 lines of code. Yeah, 2 test cases are passing. Submit. Yeah, 100% accuracy. Thank you guys for watching this video. Bye bye.